In this second of the Unix command lectures, we're going to go over some more intermediate Unix commands, including concepts related to file permissions. The concept is something called a soft link, and so forth. What you're looking at here is, once again, a terminal emulator screen logged in to the working account we've been using, the JDO account. As with the prior lecture, please stop the lecture at this point and log in yourself to your Unix account and be at the root directory, or at your home directory, I mean, and follow along with the commands we're doing here, and be prepared to send a transcript of that session to show that you did in fact perform all these commands and try them out. Now, first thing I'm going to do is, if you recall, we were working with a 101 directory, and beneath that lab1. So another thing I'm going to start doing is asking you to do what I say I'm about to do in advance. Pause the lecture, do it, and then I'll do the command as well. So I want to go down to the 101/lab1 directory and be in that directory. Pause, do that. Coming back, what you should have is something like 101/lab1. Remember, you don't need the slash at the beginning. That would be rooted at the top directory, the root directory. We're doing this relative to the home directory. And then I want you to do a long listing, please, of all the files in that directory, showing their date of creation and so forth. Again, pause and come back. And what you should have done is ls-l, like that. Okay. Now, we're going to take a closer look now. Oh, I'm sorry. And then do a long listing with all of the files, including those beginning with dot. And again, pause, and you should have come back with ls-al. So there's the dot and dot entries shown as well. Okay, what we're going to do now is take a look at these permissions that appear on the left-hand side of the long listing and what they mean. The Unix permission system recognizes three kinds of access to a file, or as we'll see, a directory. And those are read, write, and execute. Read and write are obvious enough. If you have read access, that means you can look at the file. If you have write, you can change it. Execute's a little more subtle. It means that you have the right to execute the file as a command. And one of the things about Unix is that any file can contain an executable program, similar to what would be a .exe file, for instance, in Windows. But you don't need the .exe suffix. Any file might contain executable program code. And if so, then you will find that it is labeled with execute permission, and you can run it as a command directly. We'll be doing that ourselves in a little bit in a later lecture when we talk about compilation and making our own executable files, but execute permission then applies to that. Along with the three different kinds of permissions, there are three different groups of people to whom you may grant permission. The first is simply yourself. Your own right to access the file can be adjusted. In the case of the files we're looking at here, bottles.c, longsong, these three symbols right here, RW and dash, are my permissions, the owner's permission. I have read and write access, but I do not have executability access, and that's because bottles.c is simply a text file, not something that I can run as a program. The next group of people of interest is your group. Users are put together in groups. All the students, for instance, often in a university setting, are in one group, professors in another group. And you might want to provide permission to related users, but not every user. And if so, then you set group permissions. Most commonly, however, group permissions are set to be the same as the final set of three symbols, which are everybody's permissions, often called world permissions. And this applies to every user on the system. That last, then, R dash dash, indicates that everyone can read bottles.c. I'm allowing that to be generally accessed as a file. And also my group can, but only I can read and write it. No one else can modify it but me. Same permissions, of course, apply to longsong. Now, there is an initial dash here that apparently is not part of the three symbol pieces for owner, group, and world. That initial dash is a special flag indicating whether or not the file in question is a directory. And Unix tends to view directories as a sort of specialized file. Indeed, they contain within them a listing of the subdirectories and where they can be found on disk. You don't normally read the contents of a directory file in raw form. You instead do ls and that sort of thing that will show it to you in a readable form. But it is nonetheless a kind of file, a directory. And those that are directories are labeled with Ds. As you can see, both dot dot and dot here are directories. So that's kind of included with the permission flags on the file. Directories can have permissions as well for, again, the owner, the group, and the world. The directory dot, for instance, my directory, has read, write permission by me and execute permission. Well, execute sounds a little strange. We'll get back to that in a minute. But first, the read and write permission. What does it mean to be able to read a directory? Well, it means that you can ls the directory and show the files and subdirectories that are within it. To be able to write a directory? Well, that would mean you can create new files in the directory. You're modifying, in essence, the content of the directory by doing that. And you can remove files from the directory, again, if you have write permission. So modifying what's in the directory is what write permission grants you. And evidently, I have not allowed anyone else to do that to my directory. They may look at it, they may ls it, because everyone else has R read permission, but they can't write the contents of my directory, can't change what's in it. What about the execute bit? Well, you've seen that in a number of cases, for instance over in the grade C Staley account where we looked for files to copy, we descended down through a series of directories. It started at the home directory for grade C Staley, then beneath that 101, lab 1, and so forth. The process of descending down through directories on your way to some file down the line is separate from being able to ls the directory. Being able to go down through the directory to things below it is what the execute permission bit means when you're dealing with a directory. Because, you know, it wouldn't have any meaning otherwise. You can't execute a directory as a program. So they kind of repurposed the execute bit, execute permission flag, I should say, to indicate that you can go down through a directory. That's a fine but important distinction, and we'll look at some of the effects of it a little later when we examine grade C Staley. So that, in a nutshell, is Unix file permissions. Then the question is, how do you change them? Let's say, for instance, I don't want the rest of the world looking at my bottles.c code. I'd like to keep it private. A good idea, by the way, if you're working on project assignments in the class, especially if you're under an obligation not to share code, a good idea to make your files not readable by others. The change mod command changes permissions. You might think it would be called change permission, but unfortunately no. The collective permission flags and that directory flag are referred to in Unix speak as the mode of the file. And so change mod is the name of the command that changes that. Now, the change mod command takes a second, or first an argument right after change mod that says what permissions you want to have for the file, and then the name of the file whose permissions you want to change. I'm going to type in something here, and we'll talk about it. I'm going to change the permissions on bottles.c, and I'm going to give the number 600 to be the permission pattern I want. Now, there are a couple of different ways you can use change mod, but the one I want you all to learn is this somewhat techie approach to setting permissions. Every possible pattern of read, write, execute, read, dash, execute, etc. has a numerical equivalent. 600 is the pattern for read, write for me and nothing for anybody else. So I'll make that command change and then do an ls-al again. And you can see that I've now changed bottles.c to be 600. Read, write for me, zeros, or nothing for everybody else. Now, knowing the numbers that you use for different permission patterns is something you can do simply by memory. But there is a very techie rationale behind the fact that 600 represents RW permission for me only. And I've got a little chart in the handout that you'll have for this lecture as well over here that'll help out. I've listed some common file permissions, as you can see, and I've for instance got rw-r-r-, and another one here which is the one we just set, some other possible patterns that might be commonly used, and then beneath them I've listed the corresponding 3-digit number that represents that permission pattern. For instance, with read for everybody else it's 644. with read and write only for me, 600, as we just said. If I wanted read, write, and execute for me, read and execute for others, 755. And 711 if I want just the execute for others, but not the read. Now, there is a pattern going on here. If you think of each of the three group flags, each of the groups of three flags, I should say, as a small binary number, and we haven't gotten that deep into binary numbers yet, but you may be aware that they are a series of 1 and 0 values. So R, W, and no permission, no execute is 1, 1, 0. R and no other permissions is 1, 0, 0. Wherever there is a flag turned on, we have a 1. Wherever there is a flag turned off, we have a 0. And we can then think of these as groups of 1s and 0s, switches turned on and off. You can then go one step further if you are comfortable with something called octal notation and read these as base 8 numbers, which is what the 644 is actually supposed to be. But that's past the scope of an introductory class, and I'm not going to ask you to do that. There's an easier way to deal with it, and that is just to memorize these 8 single-digit values. All turned off is a 0. Only execute turned on is a 1. Only write turned on is a 2. Write and execute a 3, and so it goes throughout these 8 possibilities. If you're familiar with binary numbers, you'll recognize that I'm counting upward in binary from 0 to 7. This is 111, read, write, execute, and that would be a binary 7. But you can also just remember the numerical values for these 8 possibilities, and then to do a permission, you glue together the appropriate numbers for what you want for yourself, a 6, what you want for other people, a 0, and for your group, a 0, and then for everybody else, a 0. Or if I want read, write, execute for me, that's a 7. Read, no write, and execute for others, that's a 5 for the group, and a 5 for the rest of the world. You'll find that there are only about 4 or 5 numbers you ever use, and you pretty much memorize them. So the kind of weenie bit-based octal thing is not essential to using this command. Just knowing the patterns and the numbers that go with them is enough. Now, going back to our permissions thing here, I've made bottles.c not readable by the rest of the world. Let's do something a little more drastic. Let's make it not even readable or writable by me. Can I turn a file permission off to the point where even I'm not allowed to read it and write it? Stop and pause the lecture and think about what change mod command you would do, and in particular what you'd give for the 3-digit number that would mean nobody gets anything. Coming back from a pause, I hope you came up with 000 bottles.c. And so we'll change the command, change the mode for that. Let's see what we did to ourselves here. Yeah, there it is. No write, no permissions for anybody, no access for anybody. Is it really that bad? Let's see, what if I want to more it now and look at it? Yeah, I'm not allowed to. It's my own file, and I still can't read it. And this is, of course, what someone else would get if they tried to read this and you had not set read permission for them. More commonly, that's the kind of situation you'd see. But you can even do it to yourself. Fortunately, you are, by the way, able to change the permission back. If I wanted to change mod again to 600 as I did before, I can change it and then be able to read it. So you always have the opportunity to adjust this if you do make a file unreadable to yourself. But I'm going to try something slightly different here. I want to remove bottles.c. Now, at a glance, I would think that's not allowed either, right? I'm not allowed to write the file. Surely I can't remove it. But in fact, what it will do is give me a warning, ask if I want to remove the write-protected file bottles.c, and that's a prompt there, a modal prompt, right? We're in a mode here. We're talking to the remove command. And so my appropriate response is Y or N, yes or no, and we'll say Y. And let's see what happened. Gee, I removed it. But I thought I didn't have write permission on it. Well, removing a file is not technically an act of writing on that file. It's an act of writing in the directory that contains the file. What I did was I modified the content of the directory to drop that file out of it. So what I needed to have to do a remove, in fact, was write permission on the directory in which the file resided. And I do have that. The dot directory allows me read, write, and execute permission, my own directory here. And so I was able to remove. Creating a new file also is a matter of having write permissions on the directory, as I said earlier. So we got rid of bottles.c, Let's try removing something more dramatic here. Now, I want you to look at that command before I execute it, and you should find it perhaps even mildly amusing. Be sure you see why. What I just asked to do here was remove every file in the grader account, something that would probably piss your professor off if you actually were able to do it. This is someone else's account we're dealing with here, grade C Staley, and the apparently master files for a class exercise. Can I blow them away? Well, let's see. Oh, it actually asks first and says, do you want to do this for sure? And I say, yes, I'm not allowed to write that file. But then it immediately says, no, you're not allowed to do that. And it's going to do the same thing to me for song. So it's a bit of a tease, but the bottom line is I didn't get to remove those files. And that's because, of course, I don't have write permission, let's see, on the files, right? Pause and think about that. Is it because I don't have write permission on those files? And you should come back from thinking about it and saying, no, that's not the issue. It's that I don't have write permission on the Lab 1 directory in grade C Staley. That I'm not allowed to modify the content of, and so I can't remove files from it. And that's the actual reason I'm forbidden here. I'll give you a brief aside story. I knew a student at UC Santa Barbara about 20 years ago or so who was a bit of a cut-up, and this guy was messing around with one of the professor's accounts on Unix, and he looked over into the account and found that it was readable to him, and also that it was writable to him. The professor had left his permissions incorrectly set, and he did an RM star on the professor's account. By his telling of it, it's because he couldn't really believe that he was able to remove all those files, and he was just trying it out. But the bottom line is he removed every file in one of his professor's accounts by horsing around with an RM star command and poorly set permissions on the part of the professor. As you can imagine, it was a story told and retold in the department for a month later. So let's see here. We've now found that we can't remove things over in grade C Staley, fortunately. Let's confirm that, by the way. By the way, I'm going to do a little Unix shorthand here. I just tried to remove this argument, grade C Staley 101 lab 1 star. You can repeat the last argument in the prior command with another one of these exclamation point shorthands. Bang $sign. Exclaim $sign means whatever the last thing in the prior command was. It's surprisingly often you want to do that. So that'll be the equivalent of this here, because my remove command was the most recent one I did. And I'll get an ls-l of those files, which, as we can see, are untouched. And now, having just reminded you of the dangers of RM star, let me introduce an RM option you might like as an alternative here. -I. I'm going to do a -I RM star on my current lab 1 directory, which will get rid of the long song file as well, but it'll ask me before it blows them away. So I get to make sure that I really wanted to do this, and I'll say yes to that. Any file I was deleting would have been so queried, and so it's a safer RM to use RM-I, and probably a good idea never to do RM star if you can get by with RM-I star and feel good about typing a bunch of yeses. Okay. I now have cleaned out my lab 1 directory, and I want to copy files back over again from my grade C Staley directory, but I'm going to do it in a slightly different way. You recall earlier that I did it by doing a cp command, tilde grade C Staley 101 lab 1, and copying a file over from there by cp command. What I'm going to do now is an ln-s command instead. The ln command stands for link. And you always use it with a -s option, almost without exception. So you can almost think of it as a unit command, though there is a space needed before the dash, as always. After you've said ln-s, you give the same kind of arguments, exactly the same as you would to copy, to cp. So what I'll do is give it grade C Staley /101 /lab1 /star. Copy all those files over to my current directory. And they're copied, bottles.c and song, as expected. But they weren't actually copied. It's a little different. I'm going to do an ls-l here and see what we got. The entries for bottles.c and song now are listed with the name, but then an arrow, and if I read around the line wrap here, pointing to the other file in the grade CStaley account. You can do this in most operating systems. You can set up a file that is in fact not an independent copy, but a reference back to some other file elsewhere. In some cases they're called aliases. They are in Windows, for instance. In Unix the term is soft link, but the effect is the same. I'll be able to treat bottles.c as though it were a file in my directory, but in fact I don't have an independent copy. And I'll only be able to do to bottles.c whatever I'm allowed to do to the bottles.c that it refers to in grade CStaley. I can read it, in other words, but I would not be able to modify it or write it because I don't have write permission on that file. This is useful especially for files whose content you don't plan to change, and you don't want to use up extra disk space by making an independent copy. And above all, you'd like to be sure that if the original is changed, your copy is automatically updated with it. So do prefer using ln-s when you copy stuff, especially read-only files, from the grade CStaley accounts in the class. That way you'll be sure you have the up-to-date version always. A brief aside on the permissions, by the way, you'll notice that the permission shows RWX, totally universal permission on this soft link. That's misleading. It doesn't mean you really have access like that to the original file. It's the link itself that is that widely modifiable. And it's even marked as a link, by the way, with that initial flag showing L instead of D. So that doesn't affect the file it refers to. It has its own permissions, and those are what are enforced for that file. Okay, now I'm going to go up one directory, and you should remember that that is, pause if you need to, cd ... and I'm going to be in the 101 directory. I have the lab1 subdirectory beneath that. I'm going to try removing the lab1 directory. Can't remove it. It's a directory. So the rm command only applies apparently to files, although we'll see there's a variation on that in a little bit. There is an rmdir command to remove directories. And it allows you to remove a directory, but as the error message here shows, only if the directory is empty. You have to go ahead and clean the directory out entirely first, and then you can remove it. Now that is one slightly tedious way we could get rid of lab1. Go down, do an rm star in lab1, come back up, do an rmdir. But there is a quicker way to do it as well. You can, in fact, use rm to blow away a directory and everything beneath it. Even subdirectories and sub-subdirectories, the entire tree of subfolders or subdirectories beneath a certain point can be blown away in a single rm command. So if you thought rm star was dangerous, now we've got even more danger here. What flag would do that? I'm going to introduce now the man command. This is Unix's rather poor substitute for help pages, and it's used by typing the word man, which stands for manual, and then some command, like rm. What you'll get back is an ultimately geeky help description, and they are at least of standardized format. The name of the command, a brief description of what it does. Apparently it does remove directories under the right circumstances, files or directories. Synopsis of how you run it. rm and then options and then files you want to remove. A brief description. And then most usefully, and by the way this is being listed with less or more so I can do my scrolling thing. And I'm in a mode here which I can't get out of until I hit Q to quit. There are all the options described below. For instance, there's that -I option we were looking at that prompts before every removal. And apparently a variation on that prompts before removing more than 3 files. I guess in case you want a less intrusive, as it says, -I, but still gives you some protection. And so we go, a whole lot of different options. Some of them multi-word options. You do have that in Unix, usually with -- and then a long description. Here's the one we're actually looking for. -R. Removes directories and their contents recursively. The term recursive in computer science means in repeated patterns, repeating down as far as you need to in a tree structure of one form or another. So recursively here would mean remove the directories, its subdirectories, their subdirectories, all the way down the line. Okay, so I just did a Q to get out of that. And now I'm going to type rm-r lab1. And wow, no response at all, which means that the command succeeded. And there we go, gone. In fact, the notoriously ultimate horrible Unix command is rm-r/. Right? Now, think about what that means. Pause and come back from the pause, and what you should come up with is that that means remove the entire file system, / being the root directory of everything. Destroy the entire file universe, as it were. Now, I don't have permission set to do that, so I won't be able to do it, but frankly, even having it on my screen scares me enough that I'm not about to hit return here. We'll just backspace over that. Again, rm, a very dangerous command. Now, if you're using man and you don't know what you want, what command you want, how do you do a general like search lookup on keywords? The man-k option will do that for you. And that, I've forgotten what K stands for, sorry, but it means do an indexed lookup. Maybe I didn't know what the remove command was, so I do man-k, and I just type remove. And back will come all the commands in the system that do various kinds of removal, that basically have remove in their brief description. So somewhere in there is rm, but there's also rmdir to remove empty directories. There's a command that removes columns from a file. You can modify a text file and drop out, say, columns 5 through 10, good for tabular data, and so on. A bunch of different things in here for removing various types of stuff. You could do a man on any one of those now and get detailed information, albeit sort of geeky descriptions. Okay. Now, having removed everything from 101, let me briefly illustrate that rmdir option actually working. I've now moved back up by the cd ... to my home directory. Underneath is the 101 directory, but it's empty. So I can now blow it away entirely, and my home directory is now back to 0. So once again, as we've done so many times before, let's do a copy of stuff over from the grade C Staley directory. But here again, I'm going to do a special CP option, cp-r Staley-101 dot. Now, the -r option in removement do it recursively. It also means that in copy, I'm giving the name of a directory, tilde grade C Staley 101, and I am asking to use that as the source, and then the current directory as the target. That will not copy just the directory across, it'll copy everything below it, recursively. It'll copy the lab1 directory, all the contents in lab1, and so forth. That's what the -r makes happen. So it's a very quick way to do a big copy of an entire directory tree from one place to another. And what we'll see is that I now have 101, and beneath that lab1, and beneath that bottles.c and song, all in one nice copy command. So that summarizes our intermediate Unix command discussion here. Let me leave you with one of the nicest conveniences in most Unix shells these days. It will probably work on your account as well. You may have noticed when I did the lab1 that I didn't type the entire lab1. I did this instead. Go up here. Did cd, I typed L, and then knowing that lab1 was the only directory within there, I did a tab command, tab key, and it automatically completed the file name for me. In general, if you're using a command and typing a file name and hit tab and it's clear which file is meant from the prefix you've typed so far, it'll just fill it in automatically for you, and it's a nice convenience. Worth, by the way, exploring these kinds of things about Unix. The more you learn these little tricks, the faster you can work with a textual session. So let's see, the next things to look at are either a VI editing tutorial, which will follow on this one, or a tutorial on doing C compilation, probably the VI first and then the C compilation.